Okay, so we're looking at linear equations. And you guys all should know now how to calculate the gradient of 2 points. So let's say the first point is 3, 7, and the second point is 2. No, let's go harder. Let's make it 5, negative 3. Okay, what's the first way we can solve this?
And y1 minus y2 over x2 minus y1.
Yeah, exactly right. And this is the gradient formula, if you didn't already know that. So let's just write that in. Gradient formula is that one there. Okay. Now, we're going to assign the first coordinate A to be coordinate 1 or coordinate 2? Judah? Coordinate 2, you reckon? Okay, so that would be x2, y2.
Yeah.
This would be coordinate 1 then, so this is going to be x1, y1. Alright, let's plug in the values, see what happens. So y2 is here, 7. And y1 is there, negative 3. So we have a double negative scenario. x2 is here, we have 3. And x1 is there, it's 5. So 7 plus 3 makes 10. 3 take away 5 is negative 2. Our gradient is negative 5. Okay? Now, had we labeled this one the first coordinate, this one the second coordinate, would the gradient have changed? No, same answer. Okay? So let's graph it and see what's going on. 3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7 is there. So there's A. And 5, negative 3 is here. 1, 2, 3. And so it's a very steep sort of a slope, isn't it? Okay? In fact, it's negative 5 down for every one across. So let's check that and verify that it's true. 1, 2, 3, 4, 5. Did we go 1 across? From 3, we should have gone 1 across to there, so that looks alright. And then if we go down 5 again, 1, 2, 3, 4, 5, we should have gone across from there to there, and we did. So that looks right. So this is the gradient, m is equal to negative 5. That was our rise over our run. Yeah, makes sense? Yes. Algebraically, graphically. Okay, so what we're about to do now is we're going to solve the equation of a line given a gradient and a coordinate. All right. There's your formula. So if we said that the gradient is negative 5, which is what we just used, and we said that we want to come up with the equation that goes through 1, 2, 3, 4, 5, 6, let's say 7, 3, 1, 2, 3. Alright, I'll say that again. We want the equation of the line that goes through that point, which is also parallel to this line. Okay? So let's say that this is a line that goes like so, and we're looking for this equation. They're parallel, but it goes through that point. Do we know what the gradient is of this line?
Yeah.
Yes, we do. What is it?
Negative 5.
Negative 5 over 1. That's right. Do we have a point on this line?
Yes.
Yes, we do. It's right there. Okay? And looking from the graph, we can tell that the y-intercept is going to be way up here somewhere, nice and high. So it could be perhaps 20, 25, might be a ballpark figure. Okay? So we've got the gradient. Do we have a coordinate? We're going to use 7, 3. And we're only using one coordinate, so I'm going to call this one x1, and the 3 we're going to call it y1. And at this stage, you just plug in the values and we're done. So, my blue is done. M is -5. That's the variable x, that's the variable y. We're not plugging in anything into the y and the x. There's x1, which is 7. There's y1, which is 3. And now we just expand and simplify. -5x plus 35 plus 3 comes up with -5x plus 38. That's the equation of y. And we're done.
Oh, I see.